Okay, so here's one version of that boomerang generation problem on the chapter 9 web assignment exercises, and they're telling us to test to see if the proportion of young adults who are back living at home is greater in 2012 in the 2012 survey versus back in the 2000 survey. So they told me the data told me, and so I've got, let's see, where's my pen here? So I know this is N, no, they told us N, and then that's the number of successes. And let's see, they want us to do population 1 is the people that moved back home in 2012. So if we're going to do, so this is 2 independent samples, they're about proportions. So I'm going to run that 2-sample, 2-proportion z-test. So, but first off, I probably want to set up HO and HA. So HO is the proportion of students that are living back home with their parents in 2012 is exactly the same as the proportion of students or young adults that are back home, back home with their parents in 2000. That any variation, any difference can be explained by random chance, random behavior. Then H1 or HA is if they're making the claim is the claim. The test claimed the greater proportion of young adults moved back home with their parents in 2012 and 2000. So 2012 proportion is bigger than the 2000 proportion. Now, it may be when I start doing this, I might find that I'm going to get a negative z-score, and I might want to switch the direction of this. Right now I have H1 to be the claim. I might change my mind and switch that to HO being the claim B, because that would represent that 2012 is the same or higher, and the thing with testing is that it's lower. It would come maybe it's lower. But let's see what happens here. Then we can go there. So now we're going to run. We got to run the test statistic and find the p-value. And so let's see. So I'm going to switch this to 2 proportions. Group 1 was the 2012 people, so that's 808. Whoops, 808 out of, let's see, 808 is the N, and 194 is the X, and then for the 2000s it was 18, 14, and 282. So this does look higher than that. So it looks like I have these hypotheses will be set up right. So now I'm going to run my click test the significance. I'm going to make greater than. Let's see what happens here. So I'm seeing a z-score of 5.91 at a p-value of 0. So it's very unlikely this will happen if there's no difference. So what I'm going to do is come back here and come back to this. I'm going to see how I do with this. So let's see, what am I saying? The test statistic is 5.19. Good. They only want two decimal places, so that's good. That's not going to cause me a headache. What is the critical value of z? So let's find that critical value of z. So let's see. I am seeing. Let's see, if I look at my critical values of z here, I'm going to try to zoom this in a little bit, show the video. Oh, I'm flipping it. That's not what I want. I want to, oh, here's what I want to do. I want to zoom in. I'm going to look down at that little mini table. I have a right-tailed test. It's a z distribution, I know. And what level of significance do they have in this test? 5% significance level. So it's a right-tailed test, 5% significance level. I'm seeing a 1.645 as my critical value. I'm going to reject HO because my test statistic is bigger than my critical value. Or if I go back and think about that p-value, where's that screen? The p-value said this is a 0 probability that this could happen if there's truly no difference in the proportions. I want to reject HO, and then we got to make a conclusion. Let's see, the data supports the plan that a greater proportion move back home with their parents in 2012 and 2020. I think that's the right answer. There's not enough data. No, that's not true because you reject the HO. I'm going to go with choice B to see how I do. Okay, let's see how I did. The test. It gave me all 4 points for that question. So that's how I did this question using that Rossman Chance applet. I really encourage you to just use an applet, not follow that formula. Okay, so hopefully this will help you answer your question.